Okay, guys, last thing, right? Last quadrilateral, last new thing. It's the kites, and a kite is not just something we fly in the air. It is a geometric figure for ourselves, right? And if you take a look at this geometric figure, you can see that does look like something something you'd fly in the sky, right? I can drag this around for myself, right? Drag this around, okay? But the key attribute of it, and if I measure these, right? 1, 2, 3, 4. The key attribute, what by definition makes it a kite, is that you have two pairs of congruent adjacent sides. Okay, so let's go to our chart here and add that in. Right, it has two pairs of congruent adjacent sides. But not all sides congruent. Okay, that's a key thing. It's not a rhombus. A rhombus has all four sides congruent. A kite has only two. It has two pairs of congruent sides, and those are adjacent. They're next to each other for ourselves, just to remind ourselves. So the kite, right, just to put this into a diagram, that's what we're saying right there, something like that. Okay, so let's take a look at the properties we're going to have for it. Okay. So if we go back to our diagram here, well, let's measure some angles, because it's always good to measure angles when we're doing this, right? So if I measure my angles, right, you can see that there's some angles that are obviously not congruent. Like if I'm looking at that, that's an obtuse angle, and that's obviously not congruent to that one, right? And okay. Measure all my angles. So all my angles are measured there, and you can see some of the numbers better than the others. So let me try to put them in the spot we can see them. Okay, and I can make this large. Oops, that's not what I want to move. Okay, I want to move this. Okay, there we go. Now we can see it better because I'm moving around. So, okay, so we can see we have some angles congruent to each other. Let me drag this point around and change it, okay? And we can see that no matter if, as I move this around and move either point, you can see that these two angles right here are always congruent. Now, if we look at the location of them, we can see that those are the angles between the non-congruent sides, okay? So there's one pair. All right, let's go and write this down for ourselves. Okay, all right, so the angles between non-congruent sides are congruent. Okay, now that's kind of wordy there, so let's just give ourselves a diagram, right? If we take a look and we draw ourselves, here are the congruent sides. The angles that are between the non-congruent sides, those are the angles that are congruent. That's what we're saying right there. And those are the only ones that are congruent. The other two were not. You saw like one's acute, one's obtuse, right? And it's not going to be true. So we're going to use that for ourselves. We're going to always have those angles congruent there. Okay? And just for what it's worth, right? This is true because if I were going to draw in a segment here, like this, the two triangles that I have here, this triangle and this triangle, you can see that they're congruent. I know they're congruent because I have side angle side, side angles. I'm sorry, I have side side side, side side side. So since these sides, the three corresponding sides are congruent, these two triangles are congruent. Okay. Okay. So let's see what else. What else? Let's draw both diagonals in. And if we look at that, we can see that obviously the diagonals are congruent. But if I look at this, one of the things that, you know, when I look at the way this is drawn, and I look at these angles around here, I wonder to myself, are those angles right angles? So let's check it out and see if that might be true. Okay, yeah, it is in fact a 90-degree angle. You can see we put the little box on there for us in addition to the number. All right, if I drag it around, remember one example doesn't prove anything, but if we can do, you know, if every example is the same, then that's enough to prove it to me. All right, take a look. All right, no matter where it goes, yeah, it's going to be 90 degrees. So that is our next property. Let's add that in. Okay, we probably don't need a diagram for this one. We could just say that the diagonals are perpendicular. Okay, so that's going to be another, right, another property for a kite. Okay, the diagonals are perpendicular. Now, there's tons of properties for this one and that we can do, but I'm going to go through only one more that's important for ourselves. Okay, now if we take a look at it, right, and we were to measure the angles, notice that this angle right here is 48.6, and if I measure this angle right next to it, it's also 48.6. I don't know, I know they're all on top of each other, so let me move things around so we can see it better. Okay, if I drag this around, right, no matter where I put it, these two angles are congruent, right? So the diagonal bisects the angle, the non-congruent angle. Okay, let's see if it's true on the other side. Let's measure that other angle. Actually, let me move it around so I can find it first. Right now we're off the diagram there, so let me zoom out a little bit. Okay, right, 1, 2, 3, 33. I think it says 33.2. 2, 3. That definitely says 33.2. I can read that one better. Let's move them in a spot we can find them and drag things around and see what happens. All right, we can see that no matter where that one is, hey, those two angles are always congruent no matter what. Okay. If you look at the other angles, you can see that they are obviously not bisected. So we again have one set of angles bisected. Okay, so right, we could say, how about we say this? The non-congruent angles of a kite are bisected by the diagonals. Okay? The non-congruent angles of a kite are bisected by the diagonals. Okay. Last thing, look at these triangles. Hey, they may not all be congruent, but they're all right triangles. Okay? Yes, some of them are congruent. These two are congruent. These two are congruent. Okay, right? But we have right triangles as well. So we'll just say for our property, diagonals form right triangles. Okay, and there you have that property. Okay. Oops. So let's go and do some examples here for kites. Okay, so got to have that chart out. Okay, so these sides are congruent. Okay. Oh, I can find that this is 12 then as well. That's good. Oh, this is the angle between the non-congruent sides. This is also going to be 94, right? Because remember, the angles, right, that are between the non-congruent sides, those are congruent. If I'm looking at this top triangle here, it's a triangle for myself. So I know it had to add up to 180, so I have 94 and 28 together, right? That gives me 122 subtracted, so I got 58 left over, right? Remember, these two triangles are congruent, so this is going to be 58 degrees, and that's 28. Or you could also think of it as this diagonal, that's between the non-congruent angles, that's going to cut it in half. Right? That bisects, right? So we got those angles. It's not possible for me to find any of the other measurements because I just didn't have enough there, so I leave that blank. Okay. Okay. Let's try the next example. Next example. Okay, these two are congruent. That means these two are congruent. Again, it's a kite, so you have to have two pairs of congruent sides. That's how I know that's 10. Now here's another thing, right? If you take a look at it and you look at your triangles, that triangle's isosceles, and that triangle's isosceles. Right, both those triangles are isosceles. Okay, okay, which means that these angles are congruent, and then these angles are congruent. Well, for this triangle, if that's 64 and that's 64, that means that I must have 52 degrees up here. That's all that's left. Okay. And let's see, if that's 98, so I have 82 left over, I cut in half. So we have 41 and 41, okay, for ourselves. Okay, so there's different things we can do here as we go through these problems. Okay, let's look at this example here. Let's see. It's a kite. Okay, this is 6. This must be 13. Okay. These are right angles, right? Because diagonals are perpendicular to each other. So I'll put the right angle mark on it. So that tells me that this right here is a right triangle. So let's do that. 6 squared equals 5 squared plus b squared. Now we got the square root of 11. Okay. We also have a right triangle right here. 13 squared equals 5 squared plus b squared. Oh, that was a triple. I could have done that. Okay. We get that. Okay. Oh, I have, let's see. This is 90 and 19. Well, I can figure out what that is, right? 90 and 19, 109. Subtract it from 180, 71 degrees. Oh, this bisects, so that's 71. That's 26. I can figure out this one then, right? Triangles left over, right? So this is almost like an angle chaser now. I have so many things I know from what we've done throughout the year to figure out the rest of those angles. Okay. Oh, that's 64 up there. Oh, that's 71. Then this is 19. Oh, this length. Oh, okay. Wait, these two triangles are congruent. Okay, so we got 5 for that. Okay, so we can just start filling out everything we can. Okay, let's see. Next example. Okay, it says it's a kite, so that's 5. These are right angles. So this triangle, oh, that's a 3, 4, 5, so that's 4. Okay. Let's see. Oh, that means there's 50 left here. These diagonals, right? 40. Oh, these two triangles are congruent, so that's 4 right there. Okay, right on. Okay. And this is isosceles, so that's 60, and that's 30 up there. That's 30 there. Hey, it's a 30, 60, 90, right? 30, 60, 90 tells me that's 8, and that's 4 root 3. Okay, so I'm using everything we've had from throughout the year, right, to help me out with these problems. All right, it just keeps going. Okay, and these examples are more of the same, right? So, right, I pause it and just try and see what you can do for each of those. Okay, see how they work, right, for you. Okay.